Hello and welcome to StudyIQ. I am your friend Rahul Saigaonker. Let's continue our discussion of NCERT Science series. You all know that on StudyIQ we are running NCERT discussion where we have already reached till class 8th. Chapter by chapter discussion is going on. Although we are in class 8, but class 6 and class 7 discussion has already been done, which is on the main channel StudyIQ IAS. You can always refer to those videos, those lectures for more comprehensive understanding of entire science from basic level. In fact, I'll be sharing the playlist of this entire science series on my social media ID, which goes with Rahul SAI222, Rahul Sai 222. It will be there on Instagram as well as Telegram. You can always go there and watch the classes. But today's lecture is about NCERT class 8, and we are doing a chapter by chapter analysis. We are already done with crop production and management. We are also done with microorganisms, friend and foe. In the last class, we spoke about synthetic fibers and plastics. We spoke about nylon, rayon, polyester, polyethylene, right? We spoke about so many things. And today we are going to talk about metals and non-metals. Okay, so this is going to be the base of your chemistry knowledge, I can say. Now in this discussion, what are we going to understand? We are going to talk about physical and chemical characteristics of both metals and non-metals, and at the end of the discussion we are going to talk about their utility. All right, that's the agenda. So without any further delay, let us begin our discussion. First things first, when we talk about metals or non-metals, these are all elements, and these elements are represented where? They are represented in the periodic table. So in chemistry, in school, we have already seen this periodic table. All right, in this periodic table, you'll find the details of the elements, you'll find their atomic numbers, atomic masses, etc. So from here, from this chapter perspective, although NCERT talks about only two things, metals and non-metals, but whenever we talk about periodic table, we can see three kinds of elements. We can see metals, yes. We can see non-metals, yes. We can also see certain specific elements which are in between these two, which are called as metalloids. So you need this common knowledge. There are metals, there are non-metals, and there are metalloids. So in this discussion, we'll talk about characteristics of metals, non-metals. But whenever we mention about metalloids, you need to keep in mind that their features or characteristics are somewhere in between these two. In fact, in the periodic table also, if you look at these elements, in red, you'll find metals. A large number of metals can be seen here, right? Lithium, beryllium, sodium, potassium, right? Strontium, rubidium, cesium, so many metals can be seen. Non-metals are quite simple to be understood. Non-metals, in fact, our body is made up of large number of non-metals. Our body is made up of organic metal as well as inorganic metal. It doesn't mean we do not have these elements. We do have these elements also. But majority of our body is made from these non-metals. Our body is made up of what? Organic material comprising of carbon, nitrogen, oxygen, and hydrogen. Of course, hydrogen is somewhere here at number 1. Now, apart from these two, the blue ones are non-metals, the red ones are metals, but in between, there are certain elements which are called metalloids. You can see here boron, silicon, germanium, arsenic, right? Whenever you hear these names, you talk about semiconductors. So their characteristics are also somewhere in between metals and non-metals. So this is, first of all, the basic categorization. Let's talk about the features in general. In fact, we'll talk about detailed features, but when we say something is a metal, it has certain basic characteristics. That is why they have been grouped into a similar kind of a group or similar grouping. Okay, why? Because they are characterized by similar traits and similar molecular structures. Why? Metals are hard, metals are shiny, metals are lustrous. In general, metals have certain properties. Whenever we ionize them, they become positive ions. That means they become cations. So these basic things we already know. And there are about 90 or more than 90 types of metals. Please remember, when I talk about these metals can be found naturally, right, as a ore, and we can also prepare synthetic elements, synthetic metals. We know that, right? Because especially in the last row, you can see here some of the names that we can talk about. Let me just erase this. Some of the names that we can talk about. This is Einsteinium, this is fermium, right? This is mendelium, this is nobelium. So these are named after the scientists. These are named after the scientists because they are prepared synthetically in the lab. So these are metals which have certain basic traits. Non-metals also have certain basic traits. Non-metals are mostly gas, or even if you find them in solid form, they'll be brittle, they'll be poor conductors of heat and electricity. And there are about 20 odd non-metals. And non-metals can be seen here. Non-metals can be seen in these two columns. These are noble gases: helium, neon, argon, krypton, xenon. These are halogens. Halogens like fluorine, chlorine, bromine, iodine, right? Apart from that, we have carbon, nitrogen, oxygen, phosphorus, sulfur, hydrogen. These are the third category. So we have non-metals, we have halogens, we have noble gases as categorization of these non-metals in general. Now, apart from this, we spoke about metalloids also. Metalloids are in the middle ground between metals and non-metals, right? Their characteristics are also somewhere in between. That means they are partially conductors of electricity, partially conductors of heat. That means somewhere in the middle. Some are lustrous, some are not lustrous. They basically have features both from metals as well as non-metals. And the examples of this can be found in boron, silicon, germanium, arsenic, etc., which I already mentioned. So this is about the basic categorization. Now let's talk about metal and non-metal, because our discussion predominantly should focus on these two from NCERT perspective. Now metals, what are these metals? Metals are generally opaque. They do not allow the light to pass through them. They reflect the light most of the time. They are lustrous elements, and they are also good conductors of heat and electricity. Whereas non-metals are generally those which lack these characters. You can talk about silicon, boron, or you can talk about any other thing. They can be in gaseous form. So in general, when we talk about metals, they are lustrous, they are good conductors, they are malleable, they are ductile, they have high melting point, they are solids at room temperature, they are sonorous. These are characteristics. And if they are not this, then they are non-metals. They form anions, they are dull, they are poor conductors, they are brittle, they have low melting point. These are some of the characteristics. Let's delve a little deeper into the physical characteristics of each. Physical characteristics of metals. As I told you, generally metals have heat resistance. That means they have a very high boiling point and they have very high melting point. So metals have heat resistance. You can talk about any of the metals, say iron, etc. You have to go to more than 1000 degrees Celsius to melt them, etc. Right? So melting and boiling points are quite high, and that is why they remain solid at room temperature generally. Apart from that, they are conductive. That means they are good conductors of heat and electricity. They conduct heat and electricity both. And I'm writing this generally. Now, this conductivity also varies from metal to metal according to its chemical characteristics, right? But in general, they are good conductors. You can talk about iron, you can talk about aluminium, silver, you can talk about copper. They are good conductors of electricity and heat. Yes. Then there's malleability. Now, malleability is the ability of the metal to be formed into sheets. Now, what we can do is we can take a metal and we can bang it continuously. What happens is we can make thin sheets out of it. That is the property called as malleability. So metals can be pounded continuously. They can even be rolled into different shapes. That's why we can find these utensils. That's why we see flat sheets of copper, flat sheets of aluminum, flat sheets of iron, right? We use them for construction, etc. So malleability is that property of metal wherein they can be made flat. Whereas they have another property called as ductility. Ductility means metals can be drawn into a wire. They can be pulled and drawn into thin wires without breaking them. That's why we have copper, which is used in our electrical wires, because copper is very ductile. Now, there are certain exceptions to these also. There are exceptions to these. For instance, I can give example of sodium. Sodium does not have any of these characteristics. Yes, sodium, it is heat resistant, yet, but it is not ductile, it is not malleable. You can give example of mercury. In fact, mercury is an exception to all these properties at all. Also, metals are lustrous. Metals, they reflect light, right? You talk about gold, you talk about silver, you talk about so many other metals, right? Now here also, again, I can give example of sodium. Sodium is not lustrous. There are some other exceptions we can find, but in general, whenever we talk about characteristic, we are talking in general. Apart from that, metals are dense. This is true for everything. This is even true for mercury. They are very dense. That means they weigh more than non-metals. It's very true. The metals are mostly solid at room temperature. Again, an exception to this would be mercury for sure. But most of them are solid at room temperature. Metals can form alloys. That means I can mix metal 1 with metal 2 to form an alloy. And that is what we use. What is an alloy? For example, steel is an alloy itself. The stainless steel that we use at home, it's an alloy of so many metals. There is iron in it, there is carbon in it. A non-metal is also missed. There is iron, carbon, we add silicon, we add even chromium, right, to create stainless steel. Yes. Apart from that, when we talk about ionization, when the metals are ionized, when they are in ion state, they lead to positive ions or cation ions. The example is sodium ion, Na+, right? There is calcium ion, yes. Then there is potassium ion, K+. You can talk about cations being created because of metal ionization. And exactly opposite of this would be with non-metals. Non-metals are not heat resistant. They have low boiling point and low melting point. They are poor conductors of electricity and heat. Their hardness is not there. In fact, many of them are in gas structure. Yes, even if they are in solid, we can break them very easily. They are not malleable. They are not ductile. They are brittle. They break. They are non-lustrous. They are quite dull. They lack that shiny surface which metals have. Apart from that, when you talk about density, non-metals are less dense when compared to metals. Physical form is mostly we can find them in all the three forms. We can find them in the gaseous form, in the liquid form, in the solid form. All the three forms can be formed at the room temperature. Apart from that, whenever they are ionized, they form negative ions. All right, so they are generally negatively charged ions, negative charge. Okay, now that's the basic physical features of metals and non-metals. Right, so let's move on and talk about chemical features. But before that, there's a small notice for all of you. If you're preparing for UPSC Civil Service examination, then this is the batch for you, and you have few hours to enroll for that. Why? Because our batch is starting from 13th May. That's the last date. So please join it. Why? Because it's the most comprehensive program, because we'll be preparing you for prelims 2024, mains 2024, interview 2024, everything included. In fact, if you clear this preliminary examination, for your mains examination preparation, you will be called to Delhi, where we are running a residential program, and the entire expenses of that residential program, including your lodging, food charges, everything is included. All the expenses are given by StudyIQ itself. Your preparation, mains, test series, everything included. And all this program is priced at just 29,999. If you want this discounted price, do not forget to use my code Rahul Live. So I'll see you in the class very early. All right. Right, let's move on and talk about chemical properties. Now, till now, we ascertained some of the physical properties of both metals and non-metals. Now, let's talk about how these metals and non-metals behave in a chemical reaction. The first aspect we are going to understand when they react with oxygen, oxidation. Right? We know oxygen is present everywhere. In atmosphere, we have nitrogen 78%, we have oxygen 21%. So, oxygen is available everywhere. So, metals, they react with oxygen. There are few metals, especially the noble metals like gold, silver, etc. They do not immediately react with oxygen. They're not oxidized. But in general, metals, they get oxidized to form their oxides. And these reactions are generally exothermic reactions. That means heat is generated. And metallic oxides are basic in nature. Please remember this. For example, what do we use extensively? We use copper and iron extensively. For example, Fe is used extensively. So iron reacts with oxygen to form Fe2O3. Now, what is this Fe2O3? Ferric oxide is basically, your ferrous oxide is basically your rust. And when you check this rust with a litmus paper, it turns blue. That means they are basic in nature. Now, there is also a difference in terms of reaction. Some metals react faster, some metals react in a slower way. For instance, iron reacts with oxygen very slowly. In fact, many of the metals, you can see here the example of copper also. You must have seen this on copper vessels. If you are using copper jug, copper glass, you must have seen oxygen reacting with copper also. So they react to form oxides, and remember, these oxides are basic in nature. Very important. Now the next question. So what happens to non-metals? Do non-metals react with oxygen? Yes. Now non-metals, let me take example of non-metal, say carbon. Okay. Does carbon react with oxygen? Yes. What does it form? It forms carbon dioxide. Now what is carbon dioxide? Carbon dioxide is, I'd say, acid. So let's talk about sulfur. When sulfur mixes with oxygen, what does it form? It leads to formation of sulfur dioxide. Sulfur dioxide is what? It is acidic. So non-metals also react with oxygen to form oxides. But again, these can further undergo reaction. Now, when they react with water, you do know this leads to formation of carbonic acid. This leads to formation of dilute sulfuric acid or even sulfurous acid. You can see here the example. SO2 mixing with water leads to sulfurous acid, H2SO3, and sulfuric acid, H2SO4 also. All right. So remember, metals also react with oxygen, non-metals also react with oxygen. But when metals react with oxygen, they lead to metal oxides, which are basic in nature in general. When non-metals react with oxygen, they lead to non-metal oxides, which are generally acidic in nature. So this is regarding oxidation reaction. Now, what happens when metals react with water? What happens when water and metals and non-metals mix? So some metals react with water. We know some metals react with water. Some metals do not react with water also. Both are possible. Now, whichever react, they form their metal hydroxide, right? Metal hydroxide. For instance, the reactivity of these metals depends on their electron configuration, basically, right? On their reactivity. Some metals like sodium and potassium, they immediately react with water, leading to formation of sodium hydroxide or potassium hydroxide, right? Now this is immediate. But some metals, say for example magnesium, in fact we have seen magnesium in our previous discussion also. If you heat magnesium, it burns very easily. But in cold water, magnesium does not react, but as soon as the water is heated, it reacts. Same with iron also. Iron also leads to reaction with water. We all know that rust formation is high whenever there is moisture. That is why we see a lot of rusting happening where? Near the coasts, isn't it? So metals react with water. Some metals react fast, some metals react slow. Some metals may not even react. For example, gold, silver, they do not react at all. But what happens with non-metals? See, non-metals, they do not react with water. That is why many a times non-metals are also used to store, non-metals are stored through water itself. For example, phosphorus. Now, phosphorus, if it is exposed to air, especially you do know some kind of phosphorus, red phosphorus, when they're exposed to air, they burn out very quickly. And that is why phosphorus is not allowed to mix with atmospheric oxygen. It is stored in water to stop it from reacting. So remember, non-metals do not react with water. Next, how do these metals and non-metals react with acids? Now, first thing is you need to remember, non-metals do not react with acids. They do not react with acid group. Non-metals do not react, but metals do react. Metals react with acids to form a salt, the metal salt, and release of hydrogen. For example, metals like sodium, potassium, they react very vigorously. Even with dilute acid, even if there is a dilute hydrochloric acid or dilute sulfuric acid, sodium and potassium, calcium, lithium, they immediately react with these acids. But some metals, they need strong acids only. You can see here, generally, the non-metals, they do not react with acids. Metals react with acid and they produce a pop. Now, this is very important. If you have seen in your chemistry lab, in your school, if you remember, you take acid and you pour some metal in it, suddenly a pop sound comes. It's not because of throwing the metal down, but it's because of burning of hydrogen. I told you what happens. A metal salt is created and hydrogen gas is created. And this hydrogen gas, it pops, right? This happens. All right? Very important. Now, next, what happens when they react with bases? Reaction with bases, both metals and non-metals. Please remember, when a metal again reacts with a base, similar kind of development takes place and hydrogen gas is released. Hydrogen gas is released. A salt is created and hydrogen gas is released. That is why whenever metal, it reacts with both acid as well as base, what happens is hydrogen gas is released, and because of this hydrogen gas, the pop sound comes. Now remember, non-metals, they also react with bases, but the reactions can be quite complex. In general, whenever non-metals react with the bases, they lead to formation of a salt and water. Remember this. It's not hydrogen gas, it's water that is formed. So there is no pop or there is no sound because hydrogen gas is not released. Remember this, okay? Very important. So what we have understood oxidation reaction, we have understood reaction of metals with water, reaction of non-metals with water. Then we have seen reaction of metals and non-metals with acids and with bases also. With base, there are many other complex reactions of non-metals. We are not going into depth of that. It's not required also from UPSC perspective. Now, another discussion is needed. Metals, they displace each other. We all know that when we looked at the periodic table, in the periodic table, based on the electron shell configuration, some metals are highly reactive, some metals are less reactive. Some metals are noble. For example, gold and silver, they seldom react. But based on their reactivity, displacement takes place. One metal can displace another metal based on its reactive potential. Now, in our previous discussion, we spoke about neutralization reaction, meaning when an acid and base are mixed, it leads to creation of a salt and water. Now, we have seen this, correct? Now, when we talk about displacement reaction, what happens here? It's a chemical reaction where a more reactive element, it displaces the less reactive element. In fact, in our NCERT, there is a very good example and exercise given from which we can learn very nicely. Now, in the NCERT itself, they told that we took 4 beakers. We took 4 beakers, beaker A, B, C, D, E, where we have mixed few things. In the first beaker, there is copper sulfate solution in which zinc granules, zinc is added to this. What happens? Zinc is more reactive than copper. Zinc is going to replace. So a reaction something like this is going to run CuSO4 plus zinc. It leads to displacement of copper and solution of zinc, ZnSO4. Zinc sulfate is formed and then copper is precipitated. You can see here reddish copper can be seen at the bottom. The same thing happens in the copper sulfate solution. If you add iron nail, this iron is going to replace copper. You can see here when Fe and CuSO4 are added, then FeSO4, that means this iron replaces copper to form this iron sulfate, and then there is copper. All right. Now, same thing when we add for beaker C, D, E, zinc sulfate, copper is added, iron sulfate, copper is added, zinc sulfate, iron is added. In I would say in all the 3 cases, nothing is going to happen. That's why there is no change. Why? Because there is no displacement reaction taking place. So that's why please remember, displacement happens when a more reactive element is replaced or displaces the less reactive elements. All right. And please remember, both metals and non-metals take part in displacement reaction. Please note this, very important point. Okay. So it is an idea connected to reactive potential. Now, this is the end of the discussion, but there is one more very small topic left out, which is again common sense based. That's why I'm not delving too much into it, because if I ask you a question, where are metals used? Where are metals used? Metals are used extensively. I see it everywhere. I have a table which is made of metal. I have a stand that is made of metal, right? I have a watch where there is a metallic structure here. So metals are used extensively. We use it for gadgets, we use it for satellites, utensils, water boilers, everywhere we use metals. Where do we use non-metal? Now remember, I told you, our body is made up of non-metals: carbon, oxygen, hydrogen, nitrogen. We have basic features, right? In living beings, we even inhale non-metals. Oxygen is taken inside, oxygen is needed. Non-metals are also very important for plants. Why do we apply fertilizers? When we say a farmer uses urea, that means a farmer is using nitrogen. The soil needs nitrogen, the soil needs potassium, the soil needs phosphorus. non-metals are also used in enhancing the soil fertility. Apart from that, non-metals are also used in many other places. Non-metals are used as organic solvents, as chemicals, as crackers in cracker industry, in water purification. Everywhere we do use non-metals also. Just keep that in mind. A simple question can be formed based on use of metals and non-metals, leading to some sort of confusion. So, but just get it clarified. All right. Right. That's the last topic of our discussion from this particular lecture. I hope you have gotten a good idea about metals, non-metals, a basic idea from the NCERT perspective. Right. So that's the end of the discussion. Remember, if you have liked this discussion, you can always follow me on this particular ID. You do know it. With the same ID, on Instagram and Telegram, I do share the playlist for the entire science lectures. All right. Thank you for watching this video again. Jai Hind.